Have you ever wondered what the oldest part of your body really is? Not your skin, not your bones, not even your heart. Something far smaller and far older. Inside you right now, there are atoms that have existed for billions of years. Long before Earth existed, before the sun formed, before life itself began. They were already there, drifting through darkness, moving between dying stars, becoming part of worlds that no longer exist. And yet, they are still here, inside you. One of those atoms may have passed through ancient oceans, through forests that vanished millions of years ago, even through creatures long gone. And one day, it will leave you and continue its journey again. This is the story of just one of them, one single atom, and the path it has taken across the universe. Because nothing in nature truly belongs anywhere. Everything moves, everything changes, everything returns. Atoms do not disappear. They are only rearranged. And in that endless cycle, they carry the history of everything that has ever existed. The carbon inside a leaf may have once been part of a dying star. The carbon inside a mountain may have crossed interstellar space for millions of years. And the carbon inside you has already lived countless lives before this one. Tonight, we follow that journey. Not a civilization, not a planet. One atom through the entire story of the universe. We begin not on Earth, but inside a dying star. Far out in the darkness, a massive star is reaching its final moments. Long before our sun existed, before Earth, before the Milky Way looked the way it does today, there was another star, far larger than the one that now warms our planet, brighter, hotter, and living a much shorter life. If someone could have watched it from a safe distance, it would have appeared calm, a steady point of light burning quietly against an endless sea of darkness. But beneath that peaceful glow, the universe was performing one of its greatest acts of creation. Inside the star, gravity never rested. Every second, it pulled billions upon billions of tons of matter inward. The deeper you traveled, the more impossible the pressure became. Atoms were squeezed together with a force beyond anything Earth has ever known. Temperatures climbed into millions of degrees. No mountain, no volcano, no explosion in human history comes close to conditions like these. Yet this unbearable pressure served a remarkable purpose. It allowed the universe to create something entirely new. Most of the young universe was astonishingly simple. Almost everything was hydrogen, a little helium, and almost nothing else. There were no forests waiting to grow, no rocky planets, no oceans, no living cells. The ingredients for those things simply did not exist. Not yet. Stars changed that. Deep inside their cores, hydrogen atoms were pushed together. When two of them came close enough, they fused, not collided, not stuck together. They became something different. A tiny amount of matter disappeared, transforming into energy. The very light that escaped the star, the warmth that spread across space, was born from that transformation. For millions of years, then hundreds of millions, the star continued this quiet work. Hydrogen slowly became helium. The star remained stable. Gravity pulled inward. The energy from fusion pushed outward, each force balancing the other, like two hands holding the same fragile world. But nothing in the universe lasts forever. Eventually, the hydrogen near the core began running low. Something changed. Gravity, which had waited all this time, began to win. The core contracted. Pressure increased. Temperatures climbed even higher. Now, helium itself could begin to fuse.
The star entered a new chapter of its life, and with every chapter, it learned to create heavier elements. Helium became carbon. Carbon became oxygen. Oxygen later helped create even heavier elements still. Layer by layer, the star became like a cosmic furnace, forging the building blocks of future worlds. Somewhere within that unimaginable inferno, our atom came into existence. Not with a flash, not with an explosion, simply through nuclear fusion. For the first time, 6 protons, 6 neutrons, and 6 electrons would eventually belong together. A carbon atom had been born. It had no awareness of its creation, no understanding of where it was. It simply existed, surrounded by temperatures hotter than almost anywhere else in the universe. Around it, countless other atoms were being created. Some helium, some neon, some magnesium. Each one destined for a journey of its own. For millions of years, our carbon atom remained trapped inside the star. There was nowhere else to go. The gravity was overwhelming. Nothing escaped. Not even light could leave immediately. A single photon created near the core might spend tens of thousands of years bouncing endlessly through dense stellar material before finally reaching open space. Everything inside the star moved slowly, despite the incredible violence. The atom drifted through currents of unimaginably hot plasma. There were no solids, no liquids, only glowing matter, moving like an endless storm of fire. And still, the star continued aging. Like every living thing, it could not burn forever. With each passing age, its fuel became harder to replace. Each new stage of fusion lasted less time than the one before it. Millions became thousands. Thousands became hundreds. Near the end, some stages lasted only days. The giant had entered the final moments of its life. Deep inside, its structure was changing rapidly. An iron core was beginning to form. Unlike carbon or oxygen, iron offered the star no future. Fusing iron consumed energy instead of releasing it. For the first time, the great furnace stopped supporting itself. The balance that had existed for millions of years began to disappear. Gravity noticed immediately. It had been waiting patiently since the day the star was born. And now, there was almost nothing left to hold it back. Our tiny carbon atom, still drifting inside the burning interior, had no way of knowing that everything around it was only moments away from becoming one of the most violent events the universe has ever known. The star that had given it life was about to destroy itself. And in doing so, it would set our atom free. For millions of years, gravity and nuclear fusion had been locked in perfect balance, one pulling inward, the other pushing outward. neither side ever truly winning. That fragile balance had allowed the star to shine across the darkness for an unimaginably long time. But balance in the universe is never permanent. Deep inside the core, iron had become the final chapter. Unlike every element before it, iron could no longer keep the star alive. Fusion stopped producing the energy needed to support the enormous weight pressing down from above. For the first time since the star was born, gravity encountered almost no resistance, and it acted instantly. The core didn't slowly shrink, it collapsed. In less than a second, matter that had spent millions of years suspended in delicate equilibrium was suddenly falling inward at incredible speed. Imagine an entire world collapsing beneath its own weight. Then imagine something even more violent. The center of the star compressed so rapidly that atoms themselves could no longer remain unchanged. Electrons were forced into protons, new particles were born. The core became unimaginably dense, a sphere only a few dozen kilometers across, holding more mass than our own sun. The collapse happened so quickly that the outer layers of the star didn't even know it had begun. For a tiny fraction of time, everything still looked normal from the outside. The brilliant star continued shining, as though nothing had changed. Then, the outer layers struck the collapsed core, and the universe answered with an explosion unlike almost anything else it ever creates. A supernova. Not simply an explosion, but the violent death of a star. For a brief moment, this single star released more energy than billions of ordinary stars shining together. Across vast distances, entire galaxies would have seen its final light. The darkness, so quiet for millions of years, was suddenly flooded with unimaginable brilliance. Shock waves tore through the outer layers of the star. Matter that had spent millions of years locked inside was finally escaping. Carbon, oxygen, silicon, calcium, iron. The ingredients of future planets, future oceans, future forests, future life were scattered into the galaxy. Among them, our tiny carbon atom. For the first time since its birth, it was no longer trapped. It wasn't choosing a direction, it wasn't steering itself. It simply was carried by forces so enormous that choice had no meaning. The star that had given it life had also become the force that released it. As the expanding cloud raced into space, something extraordinary continued happening.
The explosion itself became another factory. For just a few fleeting moments, conditions grew even more extreme than they had been inside the living star. New elements, far heavier than iron, were forged in an instant. Gold, uranium, silver, many of the rare atoms that would one day become mountains, jewelry, electronics, and even the earth beneath your feet were born during these final moments. The universe had transformed destruction into creation. Our carbon atom drifted outward with countless others. Around it, the brilliant remains of the star expanded like an enormous glowing flower, its petals stretching farther into the darkness with every passing year. If someone had been close enough to witness it, there would have been no sound, only light, an impossible amount of light, because space itself is silent. Even the greatest explosion in the cosmos travels without a single roar. Eventually, the expanding cloud slowed, not because it had reached an edge. There are no walls in space. It slowed because it shared its energy with the thin gas already scattered between the stars. The brilliant cloud gradually faded. Years became centuries. Centuries became thousands of years. The brilliant cloud grew larger, thinner, and colder. Its light slowly disappeared into the vast darkness from which it had emerged. The star was gone. Nothing remained of the world that had forged our atom except a faint expanding nebula and a tiny collapsed core still spinning silently in the distance. But its greatest legacy was no longer the light it had produced. It was the atoms it had given away. Every carbon atom, every oxygen atom, every calcium atom drifting through that cloud carried the possibility of future worlds. Without stars like this, there would never be rocky planets, never be oceans, never be trees, never be animals, never be people wondering where they came from. Our atom had survived the death of its creator. Its journey had only just begun. Ahead lay a darkness so vast that even time itself would begin to lose meaning. For millions of years, there would be no planets beneath it, no oceans around it, no life waiting for it. Only silence. An endless ocean of space, where a single atom could drift longer than human history, longer than civilizations, longer than Earth itself had yet existed. The universe had opened its doors, and there was nowhere to go except everywhere.
Then, everything became quiet. Not in the way we understand it on Earth, not the silence of a sleeping forest or calm ocean before sunrise. This was something far deeper, the kind of silence that exists only in space. Because space has no air, no wind, no waves, nothing to carry sound from one place to another. Our greatest explosion our atom would ever experience was now behind it, and ahead there was only darkness. The cloud left behind by the supernova continued expanding. Year after year, century after century, it grew larger. The atoms that had once been packed tightly inside a blazing star drifted farther apart. Some would never meet again. Others would spend millions of years traveling together. Our carbon atom belonged to neither group for very long. Tiny differences in speed, small encounters with passing gas, and the pull of distant gravity slowly altered its path. Not dramatically, just enough that over countless ages it found itself traveling alone. If you could somehow shrink yourself to its scale, the emptiness would be impossible to comprehend. There would be no nearby stars filling the sky, no colorful nebulae stretching across the darkness. Those are views we admire through telescopes, compressed into beautiful images. From inside space itself, the distances are almost beyond imagination. Even the nearest neighboring atoms could be separated by vast expanses of emptiness. The universe is far less crowded than it appears from Earth. Time also begins behaving differently, at least from our perspective. For us, 1,000 years feels impossibly long. Entire civilizations rise, change, and disappear in less time than that. Languages evolve, kingdoms crumble, mountains slowly wear away. Yet for the galaxy, 1,000 years is almost nothing. Even 1,000,000 years passes quietly. Our atom drifted onward. It wasn't searching for anything. Atoms don't wander with purpose. They simply follow the laws of nature.
Every tiny movement, every subtle change in direction was the result of gravity, motion, and chance. Occasionally, light from distant stars crossed its path. A photon, perhaps thousands of years earlier, would race past at the fastest speed the universe allows. Then it was gone. The darkness returned. Sometimes our atom passed through incredibly thin clouds of hydrogen, cold regions of space where temperatures dropped close to absolute zero, only a few degrees above the coldest temperature physically possible. In those enormous clouds, gravity worked patiently, almost invisibly, slowly gathering tiny pockets of gas together. Not today, not tomorrow, not even within a human lifetime. Gravity never hurries. It simply continues pulling, year after year, million after million. The universe has time, an almost unimaginable amount of it. As our atom drifted, the galaxy around it was changing. Elsewhere, new stars were being born, old stars were dying. Entire clusters slowly orbited the center of the Milky Way. Nothing remained completely still, not even space itself. Everything moved, everything changed. Only the pace was different. If human history were compressed into a single heartbeat, our atom's journey through interstellar space would last longer than an entire lifetime of stars. It crossed regions where almost nothing existed, then regions slightly richer with dust and gas. Tiny grains of frozen material floated beside it, microscopic crystals, fragments of older stars, molecules so delicate they would instantly fall apart inside a planet's atmosphere. Here they endured for millions of years. The farther our atom traveled, the colder everything became. Heat, so familiar on Earth, is surprisingly rare in deep space. Away from stars, the universe settles into an endless chill. Almost all the energy from the long-dead supernova had vanished. The brilliant explosion was now little more than memory written into the motion of scattered atoms. And still, our atom continued drifting. No destination, no beginning anymore, only movement. There is something strangely peaceful about this part of its story. Nothing urgent, nothing dramatic, just patience. The universe spends far more time building than destroying. It waits, sometimes for billions of years, because creation at the largest scales cannot be rushed. Then, after ages beyond counting, something changed. It was almost impossible to notice at first. The darkness was still there, the cold remained, but gravity, which had quietly shaped the universe from the very beginning, was beginning another act of creation. Far ahead, an enormous cloud of gas and dust had started collapsing under its own weight, not exploding, not colliding, simply falling inward, very slowly, very gently. Our atom, still carried along by the invisible currents of the galaxy, was drifting toward it, toward a place where countless lonely atoms, each with stories just as ancient, would meet again. Not inside the star that had created them, but inside something entirely new, a newborn home that did not yet have a name. One day, it would be called the solar system.
For millions of years, our atom had wandered through the quiet emptiness between the stars, with no destination, no purpose, only motion. Then, almost imperceptibly, its journey began to curve. Not because the atom had changed direction, but because something far away had begun to pull on it. Gravity. The same invisible force that had once compressed a dying star into a brilliant furnace was beginning another story.
Far inside one of the Milky Way's spiral arms, an enormous cloud of hydrogen, helium, dust, and ancient stardust had become just dense enough for gravity to take over. No one knows exactly what started it. Perhaps the shock wave from another distant supernova. Perhaps the slow accumulation of matter over millions of years. Whatever the cause, the balance had been broken. The cloud was falling inward, very slowly. At first, almost nothing seemed to happen. The cloud looked cold, dark, almost invisible against the blackness of space. But appearances can be misleading. Across hundreds of trillions of kilometers, countless atoms were moving ever so slightly toward a common center. Not fast, not dramatically, just enough that each passing year, the cloud became a little denser, a little warmer, a little brighter. Gravity is remarkably patient. It doesn't need speed, only time. And time the universe had in abundance. Our carbon atom was among the countless travelers being drawn inward. It passed frozen grains of ice, microscopic crystals, and atoms that once belonged to entirely different stars. Each carried its own history, some older, some younger, but here those histories no longer mattered. Everything was becoming part of something new. As the cloud contracted, it began to spin. Not because someone had set it in motion, but because nearly everything in the universe already carries a little motion. As the cloud shrank, that gentle rotation became faster, much like an ice skater pulling in their arms. The enormous sphere slowly flattened into a vast, rotating disk. At its center, pressure continued building. Temperatures climbed. Millions of atoms collided every second. The darkness that had lasted so long was beginning to glow. A new star was being born. Not suddenly, not with an explosion, but gradually, like a sunrise that takes hundreds of thousands of years. Deep inside the growing center, hydrogen atoms were squeezed closer and closer together. The pressure increased. The temperature climbed into the millions. Then, for the second time in our atom's existence, fusion began. Hydrogen became helium. Light burst outward. Gravity had found its balance once again. The newborn sun had awakened. Its first light spread across the surrounding disk of dust and gas, illuminating countless particles that had spent millions of years in darkness. Among them, our carbon atom. For the first time since the supernova, it was no longer drifting through empty space. It had become part of a vast construction site. Everywhere around it, tiny dust grains collided. Most bounced apart. Some stuck together. Then those clumps collided with others. Pebbles became rocks. Rocks became enormous bodies stretching hundreds of kilometers across. Each collision released heat. Each impact reshaped the growing solar system. It was a surprisingly chaotic beginning. There were no neat orbits yet, no peaceful planets circling quietly. The young solar system was loud in every way except sound. Worlds crashed into one another. Asteroids shattered. Molten rock flowed across newly forming surfaces. Gravity sorted everything relentlessly. Heavy materials drifted inward. Lighter gases spread farther away. The inner solar system became hotter. The outer regions remained cold enough for ice to survive. Our carbon atom, still bound to a tiny fragment of dust, joined countless others in an endless dance of collisions. Sometimes it traveled freely again. Sometimes it became trapped inside growing rocks. Then another collision released it once more. Nothing remained fixed for long. Millions of years passed. The chaos slowly began to give way to order. Near the young sun, one growing world gathered more and more material. With every orbit, its gravity strengthened. Its surface became a global ocean of molten stone. No forests, no oceans, no clouds, only fire. This young planet would eventually become Earth, the place where our carbon story would change forever. At first, it seemed impossible that such a violent world could ever support life. Its surface glowed red, volcanoes erupted constantly, asteroids still struck with tremendous force. The air, if it could even be called air, was thick with volcanic gases. No one standing there could survive even a single breath. And yet, hidden within this chaos lay the possibility of everything to come. Mountains, rivers, trees, birdsong, human voices, even the breath you are taking now. All of it depended on this restless young world slowly cooling. Our carbon atom, still carried by forces far greater than itself, had finally reached a planet. But Earth was not yet ready to welcome it. Not yet. First, the fires would have to fade. The skies would have to change. And for the very first time in its existence, the atom would meet something that had never existed anywhere it had traveled before. Liquid water.
For a very long time, Earth did not look like home. If you could have stood above the young planet, there would have been no blue oceans, no green forests, no white clouds drifting across the sky. Only a restless world still carrying the heat of its own birth. Rivers of molten rock stretched across the surface. Volcanoes erupted almost constantly. Each eruption released enormous amounts of gas into the atmosphere. Steam, carbon dioxide, nitrogen, sulfur compounds. The air was thick, hot, and completely unbreathable. The sun itself looked different too, slightly dimmer than it does today. Its light reached a world still searching for balance. Our carbon atom, after drifting through the newborn solar system, had become trapped inside a fragment of cooling rock. For the first time in billions of years, its journey slowed, not because it had reached its destination, but because planets have gravity. Unlike empty space, Earth could hold on to things. The atom remained locked inside solid rock, while the planet around it continued changing. Millions of years passed, then tens of millions. The surface cooled little by little. Not evenly, not peacefully. Massive impacts still shook the young world. Some asteroids brought destruction. Others carried something far more valuable. Tiny amounts of water. At the same time, volcanoes released even more water vapor from deep within Earth's interior. Where all of Earth's water came from is still an active area of scientific research. The answer is likely both. Some arrived from space. Some had been locked inside Earth from the beginning. Together, they slowly transformed the planet. As temperatures continued falling, something extraordinary happened. The steam filling the atmosphere could finally condense. Rain began to fall, not for a day, not for a season, but for thousands, perhaps even millions of years. Imagine standing on that ancient Earth, the sky permanently hidden behind dark clouds, lightning flashing across the horizon, rain falling onto still warm volcanic rock, again and again and again. The first oceans were not born all at once. They accumulated drop by drop
until valleys filled, basins deepened, and the planet that had once glowed red began turning blue. Our carbon atom remained inside its rocky shelter, watching none of this. Atoms don't observe, they simply become part of whatever the universe builds around them. Yet its surroundings were changing in remarkable ways. Water seeped into tiny cracks in the rocks, minerals dissolved, new chemical reactions began. The once barren crust slowly weathered under endless rainfall. Eventually, the rock holding our atom fractured. A small piece broke away, carried by flowing water. For the first time since leaving the dying star, our atom entered a liquid world, the ocean. Everything here was different. Water surrounded it from every direction. Sunlight reached only the upper layers. Below, the sea stretched into darkness. The young oceans were not like today's, rich in dissolved minerals, warmer, more acidic, still shaped by constant volcanic activity beneath the waves. Gigantic hydrothermal vents released hot, mineral-rich fluids from deep inside the planet. These chimneys created places where chemistry became unusually complex. Across the ancient oceans, countless molecules drifted together, separated, collided again. No one knows the exact path that led from simple chemistry to the first living cells. It remains one of science's greatest mysteries. But we know this: without liquid water, it could not have happened. Water wasn't simply a place where life appeared. It made life possible. It allowed molecules to meet, to react, to exchange energy, to build structures that would eventually copy themselves. Our carbon atom, after billions of years of drifting through stars, space, dust, and stone, was now surrounded by the very environment where something entirely new was beginning. Not a planet, not a star, but life. The first living organisms were astonishingly simple. Tiny cells, far smaller than anything visible to the human eye. They had no eyes, no brains, no bones, no leaves, no roots, no heartbeat, and yet they possessed something the universe had never created before: the ability to reproduce, to pass information forward, to change, to evolve. At first, our carbon atom remained outside these primitive cells, drifting through seawater, becoming part of dissolved carbon compounds, leaving them again. Its journey had become a cycle rather than a straight line, entering, leaving, returning, again and again. The oceans had become a vast laboratory. Every wave, every tide, every volcanic vent, every shallow shoreline offered new opportunities for chemistry to grow more complex. Millions of years passed, then tens of millions. Life slowly spread, not quickly. Evolution almost never moves quickly. It experiments, it fails, it tries again. The Earth was no longer just a planet of rock and water. It had become a living world. And somewhere within those ancient seas, our carbon atom was about to become part of something it had never experienced before. Not a mineral, not a cloud, not a star, but a living cell. A tiny beginning from which every forest, every whale, every bird, and every human being would eventually descend. For almost 4 billion years, life remained small, tiny, invisible to the naked eye. If you had looked across Earth's oceans then, you would have seen nothing unusual. No forests, no fish, no coral reefs, no birds crossing the sky. The planet appeared almost empty. And yet, beneath the surface, it was becoming more alive with every passing million years. The first cells were astonishingly simple. They drifted with the currents, absorbing energy wherever they could find it. Some survived, many did not. Evolution had no destination, only countless experiments played out across unimaginable stretches of time. Our carbon atom, which had spent billions of years inside stars, rocks, and oceans, finally became part of one of those microscopic cells. For the first time in its existence, it was woven into something living. Not permanently. Nothing in nature is permanent, but long enough to become part of a process that would transform an entire planet. The cell absorbed carbon from the water surrounding it. Our atom became part of a simple organic molecule. Then another. Tiny chemical reactions, each one powered by energy flowing through the cell. Nothing dramatic happened. No flash of light. No great turning point. Just chemistry. Quiet. Patient. Remarkably precise. The atom had entered a world unlike any it had known before. Inside the cell, everything was organized. Molecules moved with purpose. Membranes separated one reaction from another. Energy was captured, stored, used. The universe had spent billions of years creating stars. Now it was beginning to create biology. Generation after generation, our carbon atom passed from one cell to another. Sometimes it remained for only a few hours, sometimes much longer. Cells divided, some died. Their contents returned to the ocean. Other cells absorbed those same atoms again. Nothing was wasted. Even then, the carbon cycle had already begun. Millions of years slipped quietly by. Then, one of evolution's greatest innovations appeared. A new group of tiny organisms discovered something extraordinary. Instead of relying only on chemical energy, they began capturing sunlight itself. Photosynthesis. It may sound like a simple word, but it changed the history of Earth forever. Using light from the young sun, these microscopic organisms combined water and carbon dioxide to build sugars. Our carbon atom, floating through ancient seawater as carbon dioxide, was pulled into one of these remarkable cells. For the first time, sunlight became part of its journey. A photon, having traveled more than 150 million kilometers from the sun, struck a tiny green pigment inside the cell. That energy, captured in an instant, helped transform carbon dioxide into sugar. Our atom, which had once been forged in the heart of a dying star, was now helping store energy from another star. The process seemed almost poetic. Starlight, captured by life, using atoms born inside older stars. The universe had become beautifully connected. Photosynthesis produced something else as well, a gas that had previously been rare in Earth's atmosphere: oxygen. At first, it seemed insignificant. The oxygen immediately reacted with dissolved iron in the oceans. Rust formed beneath the waves, layer after layer. For millions of years, Earth quietly buried enormous quantities of iron oxide. Even today, those ancient rocks remain one of the oldest records of this transformation. Eventually, there was more oxygen than iron could absorb. The excess escaped into the atmosphere. Very slowly, the sky itself began changing. Most of the organisms already living on Earth had never encountered oxygen before. To many of them, it was poisonous. Entire ecosystems disappeared. Others adapted. Evolution once again began experimenting. Our carbon atom did not witness any of this directly. It simply continued moving through life, from one microscopic organism to another, into the sea, back into living cells, again and again. With each cycle, life became slightly more complex. Single cells learned to cooperate. Colonies became organisms. Time, almost unimaginably slowly, was building something extraordinary. Hundreds of millions of years passed. The oceans filled with increasingly diverse forms of life. Some developed soft bodies, others protective shells. Then came creatures that could swim with purpose, the first simple predators, the first hunters, the first escapes. Life had become a story of movement. Our atom traveled through this growing web of existence. It became part of tiny algae, then drifting plankton, then creatures that consumed them. Sometimes it remained inside a living body for minutes, sometimes for decades. Death no longer ended the journey. It simply opened another path. Every organism returned its atoms to the world. Nothing truly vanished. Nothing truly belonged to any single creature. Everything was borrowed. Everything was shared. As the ages passed, life prepared for another enormous leap. The oceans, which had cradled living things for billions of years, would no longer be enough. Soon, green life would begin climbing on bare rock. The empty continents, silent since the birth of Earth, were about to change forever. And our ancient carbon atom would be there to help build the first forests the world had ever known. For most of Earth's history, life had stayed close to water. It had no choice. The land was harsh, dry, unforgiving. Sunlight hit the surface without protection. Temperatures shifted violently between day and night. And there was no soil yet in the way we understand it today, only bare rock shaped by wind and time. But life never stops trying. Some organisms began to edge closer to the shoreline, not all at once, not as a single breakthrough, but as countless small experiments, each one slightly bolder than the last. At first, they only survived near the edges of water, where moisture still lingered in cracks, where tides still reached, where life could retreat if conditions became too extreme. Our carbon atom, carried inside simple living organisms, began to move with them, from open ocean to shallow pools to wet mineral surfaces exposed to air. Each transition was temporary at first, a brief visit to a dangerous world, then a return, then another attempt. Over millions of years, some organisms adapted. They learned to protect themselves from drying out. They developed stronger outer layers. They learned to hold water inside their bodies. And slowly, the land stopped being impossible. It became habitable. The first plants did not look like anything familiar today. There were no tall trunks, no leaves reaching toward the sky, only simple green structures hugging the ground, spreading thin across damp stone. But even this small change transformed the planet, because once life stepped onto land, it did not stay small for long. The atmosphere above it was rich in carbon dioxide. The sun's light reached every surface, and there was no competition waiting. On land, life had space to expand. Our carbon atom became part of these early land plants, absorbed through simple chemical exchange, moved into basic cellular structures, then rearranged into growing tissues. Once again, it was part of photosynthesis. Once again, sunlight became stored energy inside living matter. But this time, something was different. The environment was no longer stable water. It was air, wind, exposure, change. Plants adapted. They grew stronger structural support. They developed ways to transport water upward, from the ground to their upper surfaces. Slowly, over vast stretches of time, plants began to rise. At first, only a few centimeters tall, then larger, then taller still. What we would eventually recognize as forests began to appear, not modern forests, but ancient versions of them, dense, strange, and unfamiliar. Some of the earliest forests looked more like giant mosses and primitive tree-like plants, but to Earth, this was a revolution. For the first time, large amounts of carbon were being pulled from the atmosphere and locked into living structures on land. Our carbon atom became part of these early land plants, absorbed through simple chemical exchange, moved into basic cellular structures, then rearranged into growing tissues. Once again, it was part of photosynthesis. Once again, sunlight became stored energy inside living matter. But this time, something was different. The environment was no longer stable water. It was air, wind, exposure, change. Plants adapted. They grew stronger structural support. They developed ways to transport water upward, from the ground to their upper surfaces. Slowly, over vast stretches of time, plants began to rise. At first, only a few centimeters tall, then larger, then taller still. What we would eventually recognize as forests began to appear, not modern forests, but ancient versions of them, dense, strange, and unfamiliar. Some of the earliest forests looked more like giant mosses and primitive tree-like plants, but to Earth, this was a revolution. For the first time, large amounts of carbon were being pulled from the atmosphere and locked into living structures on land. Our carbon atom became part of these early land plants, absorbed through simple chemical exchange, moved into basic cellular structures, then rearranged into growing tissues. Once again, it was part of photosynthesis. Once again, sunlight became stored energy inside living matter. But this time, something was different. The environment was no longer stable water. It was air, wind, exposure, change. Plants adapted. They grew stronger structural support. They developed ways to transport water upward, from the ground to their upper surfaces. Slowly, over vast stretches of time, plants began to rise. At first, only a few centimeters tall, then larger, then taller still. What we would eventually recognize as forests began to appear, not modern forests, but ancient versions of them, dense, strange, and unfamiliar. Some of the earliest forests looked more like giant mosses and primitive tree-like plants, but to Earth, this was a revolution. For the first time, large amounts of carbon were being pulled from the atmosphere and locked into living structures on land. Our carbon atom became part of these early land plants, absorbed through simple chemical exchange, moved into basic cellular structures, then rearranged into growing tissues. Once again, it was part of photosynthesis. Once again, sunlight became stored energy inside living matter. But this time, something was different. The environment was no longer stable water. It was air, wind, exposure, change. Plants adapted. They grew stronger structural support. They developed ways to transport water upward, from the ground to their upper surfaces. Slowly, over vast stretches of time, plants began to rise. At first, only a few centimeters tall, then larger, then taller still. What we would eventually recognize as forests began to appear, not modern forests, but ancient versions of them, dense, strange, and unfamiliar. Some of the earliest forests looked more like giant mosses and primitive tree-like plants, but to Earth, this was a revolution. For the first time, large amounts of carbon were being pulled from the atmosphere and locked into living structures on land. Our carbon atom became part of these early land plants, absorbed through simple chemical exchange, moved into basic cellular structures, then rearranged into growing tissues. Once again, it was part of photosynthesis. Once again, sunlight became stored energy inside living matter. But this time, something was different. The environment was no longer stable water. It was air, wind, exposure, change. Plants adapted. They grew stronger structural support. They developed ways to transport water upward, from the ground to their upper surfaces. Slowly, over vast stretches of time, plants began to rise. At first, only a few centimeters tall, then larger, then taller still. What we would eventually recognize as forests began to appear, not modern forests, but ancient versions of them, dense, strange, and unfamiliar. Some of the earliest forests looked more like giant mosses and primitive tree-like plants, but to Earth, this was a revolution. For the first time, large amounts of carbon were being pulled from the atmosphere and locked into living structures on land. Our carbon atom became part of these early land plants, absorbed through simple chemical exchange, moved into basic cellular structures, then rearranged into growing tissues. Once again, it was part of photosynthesis. Once again, sunlight became stored energy inside living matter.
There was a time when Earth felt almost endless, not because it was larger, but because life had finally filled it. Forests stretched across continents. Oceans teemed with movement. The air itself carried the evidence of billions of years of transformation. And then, the giants arrived. Not suddenly, not as a single event, but through a long and patient evolution that slowly shaped some of the most remarkable creatures the planet has ever known. Some walked on land, others ruled the seas, and above them all, the world continued its quiet cycles of birth, life, and return. Our carbon atom had already experienced countless forms of existence. Inside stars, inside oceans, inside the first fragile cells of life.
inside plants that reached toward sunlight. Now, it became part of animals. Not once, but many times. Sometimes inside soft-bodied creatures drifting through ancient seas, where currents carried entire ecosystems across vast underwater landscapes. Sometimes inside early fish, their bodies moving with purpose for the first time in Earth's history. And eventually, inside creatures that stepped onto land with growing confidence. The first large animals on land were not yet the towering giants we imagine today, but they were significant. They shaped ecosystems simply by existing, eating plants, hunting smaller organisms, competing for survival. Every movement of life, every breath, every heartbeat kept the carbon cycle in motion. Our atom traveled through muscle tissue, then into bone-like structures, then into soft organs that allowed animals to sense the world around them. Eyes began to appear. Not perfect at first, but enough to detect light and shadow, movement and stillness. Life had begun to perceive itself. As millions of years passed, the diversity of life exploded. Some lineages grew enormous, others remained small and hidden, but one group would eventually define an entire era: the reptiles. From them, some of the largest creatures ever to walk the earth would emerge: dinosaurs. They were not just one type of animal, but thousands of different species, some no larger than chickens, others stretching longer than city buses. Some walked on 2 legs, others on 4. Some were predators, others grazed on ancient forests. Our carbon atom became part of this world too. Inside massive plant-eating dinosaurs, it traveled through vast digestive systems, breaking down plant matter that had once captured sunlight millions of years earlier. Inside predators, it became part of fast-moving muscle, fueling bursts of speed and power. And inside the plants they ate, it continued its endless return to the earth. Nothing about this cycle paused. Everything fed into everything else. Life had become a vast, interconnected system, constantly recycling the same fundamental building blocks: carbon, oxygen, hydrogen, nitrogen. These same atoms rearranged endlessly into new forms. Across millions of years, dinosaurs dominated the planet. Forests adapted around them. Oceans continued their slow chemistry, and the atmosphere remained stable enough to support this long age. But even dominance does not last forever. Deep in space, far beyond Earth's awareness, events were already unfolding that would change everything. The universe had not finished shaping life. It was only waiting. Then, without warning in geological terms, a new visitor arrived: an asteroid. It was not large on cosmic standards, but it was large enough to reshape a planet. It traveled silently through space until Earth's gravity pulled it in. And in a moment that would mark the end of an era, it struck. The impact released energy beyond imagination. Not just fire, not just destruction, but a global transformation. Shock waves traveled across continents. Skies filled with dust and debris. Sunlight was blocked. Temperatures dropped. And slowly, the age of dinosaurs began to end. Our carbon atom, still inside living matter at that time, was carried through this catastrophe like everything else. Some organisms survived, Many did not. Life did not disappear. It adapted, once again, because adaptation is what life does best. Forests regrew, new species emerged, small mammals began to rise from the shadows. Creatures that had lived quietly beneath the dominance of giants now had space to grow. The world was resetting itself, not to emptiness, but to possibility. And through all of it, the atom continued its journey, unbroken, unlost, still moving through the endless cycle of life and return. Because even extinction events do not end the story of matter. They only change its direction. And ahead, the planet was preparing for something entirely new. A world no longer ruled by giants, but by intelligence, by awareness, by a species that would one day look back and try to understand everything that came before it, without knowing that the answer was already inside them.
After the world cooled, after the dinosaurs disappeared, after forests reshaped themselves again and again, Earth did not slow down. It kept evolving, quietly, relentlessly. New ecosystems formed, new species appeared, some small, some complex, some highly adaptable. Among them, a branch of life began developing something unusual. Not strength, not speed, but awareness. At first, it was subtle, a slightly more advanced way of sensing danger, a better memory, a more flexible way of solving problems. Nothing that would suggest where it was going. But evolution rarely announces its direction in advance. It simply continues experimenting. And over time, that experimentation led to a species that could think about time itself. Humans. By the time our carbon atom reached this chapter of its journey, Earth had already become familiar with cycles of life and death. But something new was happening now. For the first time, a species was beginning to understand those cycles, not just live inside them, but observe them. Our atom entered human life in the most ordinary way possible, through food, through air, through water, through the same biological pathways that had existed for hundreds of millions of years. One day, it became part of a plant, then part of a grain, then part of a simple meal consumed by early humans. Inside the human body, nothing about it was special at first. It became part of glucose molecules, then entered the bloodstream, carried silently through vessels that stretched across the entire body. The heart moved it forward with every beat. The lungs changed its chemical companions with every breath. The brain, without knowing anything about its origin, used the energy derived from it to sustain thought, memory, awareness. Every cell in the human body relies on carbon, not as a symbol, not as meaning, but as structure, as chemistry, as life itself. Our atom became part of muscle tissue, then part of skin, then part of a neuron, a cell inside the brain that may have contributed to a thought, a feeling, a moment of awareness that would never be repeated in exactly the same way again. For the first time in its existence, the atom was inside something that could reflect on existence itself. Not the atom, but the system it was part of, humans. And through humans, the universe began to notice itself, not metaphorically, but physically, because every thought,
every question, every attempt to understand where everything came from was happening inside matter that once was forged in stars. The same carbon that once drifted alone in interstellar space now formed the structure of curiosity, of language, of memory. The atom did not experience this, it had no awareness, but the arrangement it became part of did. And that arrangement, you, are now reading these words, breathing, thinking, existing. At this exact moment, billions of atoms inside your body are doing what they have always done, moving, reacting, rearranging. Most of them were never yours in any permanent sense. They were borrowed from the earth, from the oceans, from ancient forests, from dinosaurs, from stars that no longer exist. Even the air you just inhaled may have passed through countless living beings before reaching you. There is no separation between your body and the world around it, only exchange, only flow. Our atom is part of that flow now, inside you, and yet it will not remain here forever. Nothing does. Cells die. New cells replace them. Food becomes energy. Energy becomes motion. Motion becomes heat. And heat returns to the environment. Eventually, every atom moves on. This is not loss, it is continuity. The same cycle that began inside a dying star still continues today, and it will continue long after this moment ends, because nothing in the universe is ever truly finished, only transformed.
Nothing in the universe stays still. Not stars, not planets, not life, and not you. Even now, as this story reaches its final chapter, the atom at the center of it all is not resting. It is moving, changing, leaving, entering, being rebuilt into something new. Inside your body, cells are constantly being replaced. Old ones break down, new ones take their place. Skin you had a few months ago is not the same skin you have now. Even parts of your bones slowly rebuild over time, at a rate so gradual you never notice it happening. But it is happening, always. Our carbon atom, which has traveled through dying stars, silent space, forming planets, ancient oceans, forests older than memory, and living bodies across billions of years, is still part of that cycle. Maybe it is in a breath you just took. Maybe in a molecule of sugar being used for energy. Maybe in a memory forming inside a neuron. But even now, it is not fixed, because nothing ever is. At some point, this atom will leave the body it is part of, not dramatically, not with any sign, just as it always has, through time, through transformation, through exchange. It may enter the air again, become part of a plant, join a tree that will stand for centuries, be carried by wind across continents, fall into the ocean, sink into deep water, be lifted again into the atmosphere, and continue, without pause, without awareness, without end. If there is a lesson hidden inside this journey, it is not that everything is connected. That much is already obvious. It is that nothing belongs to anything permanently, not even life. Life is simply a temporary arrangement of atoms that have always been in motion and will always remain in motion. Stars die, but their atoms continue. Planets change, but their matter remains. Organisms live, but their building blocks return.
Even time itself does not hold things still. It only guides their transformation. The universe is not a collection of objects, it is a process. And you are part of that process right now. As you exist, as you breathe, as you listen, you are not separate from the story you just heard. You are one of its current expressions. And one day, long after this moment, the atoms inside you will continue their journey elsewhere, not as you, but as something new, something unknown, something waiting to become part of another story. So as this journey comes to rest, there is no real ending, only a pause in narration. The atoms continue, the universe continues, and somewhere another story is already beginning, one that has not yet been told and may never be told the same way twice. The atom inside you is older than every mountain you can see, older than every ocean that moves across this planet, older than the earth itself. It has never belonged to anything, not a place, not a moment, not even a life. It has only moved from one form to another, quietly, without ever stopping, and it will keep doing so. Long after this night ends, long after this voice is gone, long after we are no longer here to think about it, it will still be traveling, through air, through water, through forests that haven't grown yet, through oceans that don't exist yet, through worlds that are still waiting to be formed, becoming part of everything and nothing in particular, as it always has. Now, as you let this settle, there is nothing more to follow. No final destination, only continuation. If you're listening before sleep, let the weight of the day fade gently. Let thoughts slow. Let the mind drift. And let everything that has been building in silence softly release. Breathe in slowly and out again. The universe is still moving, but for now, you do not need to. And that's where we leave this journey. Not because it ends, but because it continues without us watching. A single atom, carried through stars that died long before Earth existed, through silent space where time moves without sound, through oceans that were once fire, through forests that rose and fell like breathing lungs of the planet, and finally, through life itself, all the way into you. Not as something special, not as something separate, but as part of the same endless exchange that has been happening since the beginning of everything. Nothing was ever truly created from nothing, and nothing ever truly disappears. It only changes form, moves on, becomes something else. If there is anything to take from this story, it is simply this: you are not outside the universe watching it happen. You are one of the ways it happens. Thank you for being here tonight, for staying with this journey from the heart of a dying star to the quiet reality of your own breath. If you are still awake, you don't need to do anything with these thoughts. Let them settle. Let them fade. Let them become lighter as time passes. For a while now, the soundscape will continue softly in the background. Brown noise and gentle sleep ambiance, slowly holding the space as everything quiets down. No narration, no direction, just space to rest. Good night, and rest well. The universe continues its journey, and so do you.